Welcome back to Red Alt Key, your go-to channel for all things IT and technology. I'm Leslie and I'm thrilled to have you with us again. If you're just joining, don't forget to subscribe and stay updated on our Docker journey. Today we're diving into the core of Docker with Module 2, Docker Architecture. Docker is more than just containers. It's a well-thought-out architecture that powers the seamless creation and deployment of applications. In this module, we'll explore the key concepts that make up Docker's architecture. Let's get started. At the heart of Docker is the Docker engine. It's the runtime that executes and manages containers. Now, let's break it down. The Docker daemon is the background process responsible for managing containers on a system. The Docker client, on the other hand, is how we interact with Docker through the command line or graphic interface. The two communicate through a REST API. Understanding this dynamic duo is fundamental to grasping Docker's power. But wait, there's more. Next up, Docker images. Think of them as the building blocks of containers. Docker images are comprised of layers, each representing a set of instructions in the images Docker file. The layers are stacked, creating a lightweight and efficient package that contains everything needed to run your application. Now, let's move to the stars of the show, Docker containers. Docker containers are like instances of Docker images in action. Each container is an isolated executable environment that runs your application. They share the same kernel, but are otherwise independent, providing consistency across different environments. Now that we've covered the basics, let's take a deeper dive into the architecture. Docker Registry is like a library of Docker images. It's a storage system for sharing and distributing Docker images. The most popular one is Docker Hub, where you can find and share images publicly or privately. But what if you want to orchestrate multiple containers? That's where Docker Compose comes in. Docker Compose simplifies managing multi-container applications. You define your application's services, networks, and volumes in a YAML file and with a single command. Docker Compose brings your entire application stack to life. Now that we've unraveled Docker's architecture, let us install Docker on Ubuntu desktop. We're going to launch the Ubuntu terminal and then run these commands. First one, sudo apt update. The next command is this one. Yes. And the next command is this one. That's done. And followed by, let's clear the screen. Clear. And paste the next command. That's done. And then we'll run sudo apt update. Then we'll install Docker. Sudo apt install Docker CE. Yes. Then we'll check if Docker is running. And it is running, it's active. Type in Docker. There it is. Run Docker PS. We still have that problem. Docker will only run using the sudo command. So if we type in sudo Docker PS, it runs. But if we just run Docker PS, it doesn't, says permission denied. So we're going to update the configuration to allow us to run Docker without using the sudo command. Clear. Sudo group add Docker, it already exists. Sudo user mod sag Docker and the name of the username that I'm using right now. Then I'm going to restart the machine. Okay, it's back up. We're going to launch the terminal again, and we'll type in docker ps. There it is. It's running without the need to type in sudo. We have successfully installed Docker Engine on Ubuntu desktop. If we run docker-v, that's the Docker version. You can also run it as docker version. Docker is now installed. Fire up your terminal on your Linux computer and follow along. We'll explore Docker Engine, build a simple Docker image, and run it as a container. Get ready for some hands-on action. Here's a step-by-step guide to get you started. Open the terminal or command prompt and type in Docker version. This command displays the installed Docker version and confirms that Docker is up and running. We're now going to build a simple Docker image. We'll first create a new directory for this Docker project. First, let's run ls. Okay, I'll create a new directory called Docker here. And then cd docker. Clear the screen. And then we'll make a new directory called Docker project. Docker project, and then we'll cd that project folder. Okay, we are in it. pwd. We're now going to create a Docker file. Inside the Docker project directory, we're going to create a file named Dockerfile. Since I'm using Ubuntu, I'll be using the Nano text editor. So it's Nano Dockerfile with a capital D. In the Docker file, we're going to add the following context. From Ubuntu latest, and then this is a comment. This is the working directory, work dir up, and then here we are copying current directory into the working directory. Copy dot, which means copy contents of local directory into the working directory called app. Then we will run a command. And we have the prefix cmd for command. Echo, comma, hello Docker, and close. There. So close, which is Control X, then press Y to save and press enter to commit changes to that file called Docker file. Now let's use what we've just typed into our Docker file to build our first Docker image. So we'll use Docker build -t, and we'll call it super, and we'll create it using the Docker file that's in the same folder. So this command creates a Docker image named super based on instructions in the Docker file. Press enter. You can see that it's loading the build definition from the Docker file, which means it's referring to the instructions to create this image, and those instructions are in the Docker file. Transferring the Docker file, which means executing it. Then let's go here. Our first line, it had from Ubuntu latest, so it's going to the Docker hub to download that Ubuntu image. The first image, which starts with the prefix from, is the source image, which means that we are building this image using the Ubuntu image as the baseline. You'll notice as you start your Docker journey that most of the time when you build a Docker image, you use an existing image as the source or the root. And in most of the cases, the root tends to be an operating system image. And in this case, the operating system is Ubuntu. And then we scroll down here, building the context, and then is running command 2 of 3, which is defining the working directory. And then the next part, it is running the copy command, and then it exports all this and creates an image with it. Each line here or each command is a separate layer. Hopefully we'll cover this in the following modules. And then it writes the image, and we now have an image called super. So we have created the Docker image called super based on the instructions in the Docker file. Let us run this image now. We're going to type in docker run. In fact, let's clear the screen. Then docker run, and then the name of the image, super, enter, and we see hello Docker. Remember the instructions in the Docker file? The very last line, cmd echo hello Docker, which means print or display the message hello Docker. So I'll clear the screen again, and then I'll go back to that Docker run, and there it is. So as I rerun it, it does the only thing that it has been instructed to do, which is display the text hello Docker. Congratulations, you've just explored Docker Engine. You built a Docker image and you ran it as a container. This hands-on exercise gives you a taste of the power of Docker's architecture. This is a practical hands-on exercise where we'll create an Nginx container with a custom HTML file. What this means is that we will create a self-contained web server. On it, we will create an HTML file which contains web content that will be published within this container. Nginx is a web server similar to Apache or IIS on the Windows Server. We'll start by creating the project file and we'll call it Nginx. And we'll cd into it. In it, we're going to create the index.html file using nano. Specify the doc type as HTML. Close that. Specify the language. Close that. Header tag, title tag. Custom Nginx page. Close the title. This is basic HTML. Hypertext markup language. And I have a typo up there. It's not HTMK. And we'll close the head. Body. H1 tag. Hello from Nginx and Docker. Close H1. Let me add a paragraph here. This is a custom HTML page served by an Nginx container, and then close the p tag, and then close the body tag, and then close the HTML tag. So we have created an HTML page, and then H1 is a header, it's the largest header, and then paragraph text is regular size text. Then we close the body tag and we close the HTML tag. Let's save and close that. Enter. So ls, there is our HTML file. Before we build the Docker image, we need to specify the build instructions using a Docker file. Go into nano Docker file. And here we'll use the official Nginx base image. From Nginx latest, and then we'll set the working directory, work dir user share Nginx HTML. The working directory is a directory that's required by Nginx. The next thing that we'll do is copy the HTML file that we created in the previous step into the working directory. Copy index.html, and that's it. Now we'll build this image and we'll call it my Nginx. Docker build -t my Nginx, and I'm using the Docker file that's in the same folder. Enter. Builds the image, multiple layers, and copies the index.html file into the working directory. In order for Nginx to run, it needs a volume. A volume is a hard drive or a storage space that it would need to store the working directory. So I'm going to create a volume called Nginx volume with Docker volume. Docker volume create, and the name of the volume is Nginx volume. We can view existing volumes by typing in Docker volume ls, and there it is. So clear the screen. Let's run this. Docker run, and bind this to the volume. Nginx volume, and we're binding it to the working directory, which is user share Nginx HTML, and we'll open up a port. I'll use port 9005 9005, and I will map it to the internal port 80, and I'll be running the image called my Nginx. So I'll expand the window Command looks like that. Press enter. And it's running. While this window is still up, I am going to launch the web browser. Since this newly created container is in port 9005, I'm going to execute it with 127.0.0.1 9005 and press enter. There it is. The contents of the HTML file that is running in our Docker image. So if I come back here and run these side by side, and if I refresh page, you see the log. The Docker log does show my attempts to refresh this page. We're running the message hello from Nginx and Docker. This is our h1 tag and this is our paragraph tag. This is running in a Docker container. It's using the Nginx server, which is also contained within this tiny Docker container, and I'm running it on port 9005. Congratulations! You've successfully created an Nginx based container displaying custom HTML text, and it utilized a Docker volume for data persistence. That concludes Module 2, Docker Architecture. We've covered the core components, and now it's your turn to explore further. If you found this module helpful, give us a thumbs up, and don't forget to subscribe for more Docker goodness. Stay tuned for Module 3, and happy Dockerizing.